Good afternoon and welcome to today's webinar sponsored by the CTE Technical Assistance Center of New York. A few technical points to cover before we begin today's webinar. Only today's presenter will be audible, and the webinar will be approximately 45 minutes with 15 minutes for questions at the end. You may submit a question throughout the webinar by typing it into the questions pane on your control panel. All questions are logged, and any unanswered questions will be addressed by today's presenter via email after the webinar. If you become disconnected, please call 518-723-2137. For your information and reference, today's webinar is being recorded and will be available for viewing on the CTE Technical Assistance Center website at nyctecenter.org within 72 hours. If you have questions or suggestions regarding upcoming webinars, please contact the CTE Technical Assistance Center at ctetac@spnet.us.
Thank you, Gretchen. Welcome, everybody. My name is Gail Palka, and I'd like to thank you for joining us today for our webinar on recognizing the math embedded in CTE courses. Okay, what are we in for today? This overview gives us 5 points on which to focus. The first one, we're going to look at 2 principles of the NRC CTE math in CTE model. Then we're going to take a little stroll through the Common Core learning standards. We are going to reference an international benchmark and look at some of their released items. Then we're going to talk about ways in which we can recognize math, and then we're going to maximize the math. So first we have to recognize before we maximize. So I like to give people an idea about where I'm coming from today, and this was yesterday's view from the neighbor's driveway and our side yard. Yes, it's winter in the Northeast, isn't it? Well, sometimes what I would do with my students to get them writing about math is give them a picture such as this one or other photographs or whatever you like and ask them to write a caption that captured some math. So I'm going to give you 2 responses that I got from actual live students. Now, this happened to coincide with a lesson in probability, not the same picture, but a similar one. So I said, all right, why don't you try to write something about this picture, something mathy, focused on the picture. And this was the first response that I got. Chance of accumulation, 100%. Very nice, I said. Now, the second response came from a student who had just moved up from Florida, and he was not a big fan of snow at all, didn't want to ski, didn't want to skate, didn't want to shovel in particular. So, being that this was an alternative school, I wasn't quite sure what he was going to come up with. However, he kept it clean, and this is what he said. S for snow equals that, and he actually submitted it with those little asterisks. He edited himself, which I was very grateful to see. So think about ways in which you could do something similar with your students as a quick write, as a do now, as a bell ringer, something of that nature, just to get them engaged in thinking about some math. Okay. Before you go recognizing math in CTE courses, you might want to take a side trip down a math road, and you never know what you're going to see. So as you're driving along, you see a sign with the following numbers. And take about 10 seconds to see if you recognize those numbers and how they're particularly involved in some math courses. Okay, if you said they're perfect squares, yay for you. Okay, and if you were a shop teacher, carpentry, construction, something like that, you might recognize these numbers as being used when you try to square things up. So that leads to thinking about right triangles, which leads to thinking about the Pythagorean theorem, which helps us find lengths of sides of right triangles. If you remember from school, a squared plus b squared equals c squared, then perfect squares are your friend. Okay. So I referenced the NRC CTE Math and CTE Model. National Research Center for Career and Technical Education came up with 5 core principles if you're going to create this kind of model. If you've already adopted this model, then you might recognize these. If you haven't adopted this model, then it's likely that you haven't adopted a math teacher either, because the Math and CTE model likes you to pair up with a math teacher. So we're going to focus this presentation today on number 2, beginning with the CTE curriculum, not the math curriculum. And we're also going to look at eventually how to maximize the math in CTE. So again, I think you have to recognize it before you can maximize it. So on we go with some of the ways in which we can start to get our heads wrapped around some math, which of course we have to start with the New York State Common Core Learning Standards. The history of those is quite interesting. I was on a committee called the Math Advisory Council. It got set up a couple years ago, and we're no longer meeting. But the idea behind that was for us to look at drafts of the Common Core state standards, and we actually had input towards the national writing teams to give our critiques and feedback, and then we looked at the second draft and then third draft and talked about a plan for New York about how to move these out to everybody in the state. One of the things we looked at was how the writing teams used research. And one of the things they looked at were standards and international benchmarks from high-performing countries and provinces. Because the question was, well, if we're racing to the top, then where is the top, and what does the top look like in our state, in the country, and then because we're all supposed to be 21st century globally aware people, what do they look like internationally? So as you look at the list of countries, you'll see that vertical ray, there's the math terminology for you, or that arrow next to certain countries. And that arrow represents the countries that performed higher than the United States on one of the international benchmarks called the Pisa. So what is the Pisa? The Pisa stands for the Program for International Student Assessment. And every 3 years, they test 15-year-olds in reading, math, and science. They just gave a test this last year, actually, 2012, and those results for 2012 are going to be released December 3rd was the last information that I saw if you wanted to check out those results. It's really a test about math literacy. There are 4 reading subscales when you look at the report for 2009. That's very interesting because I do a lot of presenting all around the country as a national math consultant, and I hear this quite frequently. Well, this math test has turned into a reading test, right? Well, yeah, kind of. So the Pisa people, like to craft items and situations that are relevant to real life, and so that kids can be equipped to participate fully in society. As you can see on the third bullet, we ranked 17th out of 65 countries in economies in 2009. Not too bad. We are going to get back to the Pisa later on in the presentation. I'm going to show you some actual released items from the Pisa and show you what you can think about doing with them. Okay. Now, the first thing that's listed in the Common Core are the standards for mathematical practice. There are 8 of them, and what you want to do is read through the descriptions at some point and think about ways in which you can make those descriptions student-friendly so you can help your students develop good habits of mind. Now, the way that the content standards are arranged, if you remember in the Common Core, is that there are domains listed for each grade, P through 8. But for high school, they don't delineate grades. They delineate conceptual categories. So keep that in mind. Okay, the first thing we're going to do is take a stroll through the standards for mathematical practice. As I said, there are descriptions associated with each of these in the Common Core document. So just going through them quickly and sort of synthesizing the information that's listed underneath each of them will help you get a better idea of what they mean when they come up later. So make sense of problems and persevere in solving them. That's kind of the foundation on which math teaching and learning is based. Okay? And the hardest part about this one is to make sense of the problems. How do you teach kids to make sense of the problems? How do you differentiate the instruction? How do you address the needs of ELL learners and special ed students and things like that? The second part of that is the perseverance, because some of the schools at which I taught, I mean, the kids would just give up immediately, paper flies off the desk, pencil goes across the room, everybody's disengaged and disgruntled. So teaching that grit, that stick-to-itiveness is really important, and helping them chunk information to do that and giving them a good place to start helps with that perseverance. The reason abstractly and quantitatively standard talks mostly about how you move from concrete to pictorial to abstract. That is, how do you use manipulatives and hook it in with representing, say, an algebraic expression or equation? How do you get those kids to make that bridge from the concrete to the abstract? Number 3 is probably clear about constructing viable arguments and critiquing reasoning. What I found, excuse me, is you have to have a safe classroom in which to promote these arguments, and it's not about fighting. You know, it's not about name calling. It's not about, oh, you're stupid, you know. So when you learn how to do that, you can really elicit some good student thinking and listen to how they speak. Model with mathematics is a huge thing in the Common Core. Not only is it number 4 in the practices, it also shows up later as a conceptual category at high school. And that is whenever you can draw pictures, diagrams, you know, things like that. It helps especially the visual learners get a good sense of what's going on. Number 5 is the most straightforward. Use appropriate tools strategically. You wouldn't use a slide rule. You'd use a calculator, you know, something like that. Attentive precision is my favorite one, and we're going to go into that in a little more depth in just a few moments. And look for and make use of structure talks about things like, well, when you see parentheses, what do you have to do with them? And number 8, express regularity and repeated reasoning. That's simply be an observer of patterns, not only in patterns of data, but in repeated processes that you use when you calculate with 4 basic operations. Okay, so attend to precision speaks about 2 broad things. Precise communication, meaning using the most precise terminology that you can, and consistently understanding the equal sign, not as, oh, I have to get an answer, but understanding that it's about equivalence and the relationship between the left side and the right side of the equation. Somewhere in there, there's also, you know, calculate precisely, and the big thing about attending to precision is you have to get the kids to check their answers, because if they don't, then not a good habit of mind. So one way to attend to precision in everyday life. And this first example is an area code in upstate New York. I live in upstate New York. And according to my friends who live in this city, I'm technically in upstate New York, because as they like to say, Gail, upstate New York is an hour beyond the Tappan Zee, so you're technically upstate. So if there are any people involved today from the city, you know what I'm talking about. So anyway, here's the area code. If you say this number to yourself, If you're attending to precision, you'd say 607. And if you're not attending to precision, you would say 607. Now, people make fun of me for being so persnickety about this all the time, and I just think it's a riot. But O is a letter of the alphabet, and 0 is the digit. So if we're really going to attend to precision, this is one way we could kind of make that happen and develop our own habit of mind. Okay, now think about the context in which you'd give somebody an area code. You'd say it one digit at a time, right, usually. Okay, well, that's just my little O guy. If you were to read it as a number, such as the number of people participating in this webinar, it would be a totally different story. You would read this not one digit at a time, but collectively as a 3-digit number. So, ready? Did you say 607? I hope not, because if you did, this is the number you would have said. Good job if you said 607. Now, again, people pick on me. Well, you know what? Excuse me. If somebody owes me $607 and they give me $600.70, then I just got stiffed on some money, you know. And especially teenagers, they don't like getting gypped out of anything. So these days, the remainder of that would, you know, buy a couple tanks of gas. Hopefully the prices will still go down and we could buy more with that. So that's just one thing to think about. And now that I've brought that to your attention, it might be a little difficult to not pick that out, especially if you're listening to a radio station, you know, 101.5 or whatever, you know. I dare you to not hear it next time you listen to the radio. Okay, how do we hook this standard into CT examples? The first one that came to mind was cosmetology. I have a good friend who's a hairdresser, and I talked about this with him extensively. And he said, correct angles and placement of tools, because if I'm supposed to be cutting hair at 45 degrees and I do 90, you're not going to come back to my salon. I said, okay. And then I found this really neat site from the American Beauty School people. It's listed in the resources. And they had this mannequin head, and I saw these parallel lines and this text that went with it, part of which says on the right rear quadrant, the candidate will perform a weave and a slice. Now, if you think about quadrants, you might think about a coordinate plane that's divided into 4 sections, 4 quadrants. So I thought, math on somebody's head, that's really kind of cool. That's one of the things you can think of if you teach cosmetology. And even if you don't teach cosmetology right now, you might go to a salon and get your hair done. So next time you're sitting in the chair, look at those angles of those scissors. Okay. In the culinary arts, it's following recipes correctly, especially when you're baking. Cooking is a dash of this, a pinch of that, okay, but baking especially is a lot more precise. There's also the opportunity to throw a party, and maybe you have a recipe that needs to be doubled or quadrupled or something, and especially if there are some fractions involved, that can get really weird. And you'd say, well, why don't you just take out the 1/3 measuring cup, and if I have to make it 4 times that, let's just dump in 4. Well, that's true, but what's the total amount of ingredient that you're going to have? Think about that. Okay, medical assistants. I talked to my cousin this morning. She's an oncology nurse in Stanford, and she talked about temperatures and weights, especially doses of medication. I mean, you do not want to mess up there. So this actually came from a newsletter in, let's see, what date was that? Well, it was a presentation in the summer of 2012 from High Schools at Work. And if you want to look at that website, you can check the resources at the end of the presentation. Okay, the other one that's really neat to think about, because it's based in logic, is math practice number 3. It's all about inductive reasoning leading to deductive reasoning. And the inductive reasoning piece is when kids don't want to think too much because they're afraid they're going to be wrong, they're afraid they're going to look stupid, and it all boils down to they're not comfortable with ambiguity. And I don't know where to start. I don't know what questions to ask. So the second piece there is when you break down situations into chunks and try to go fast slowly instead of racing to the answer. If you go fast slowly, the answer will eventually come. Now the last piece there talks about justifying conclusions in both words and writing, and the Common Core especially is a big fan of seeing evidence of student thinking and justifying conclusions, explaining your answers, and things like that. So if you can build in opportunities for students to show evidence of their thinking and writing, that's a really good thing to do. Now, where would we see this in a few CTE examples? One of which is business, and the other is graphic design. Now, notice one is a question, what draws you into a website, and the other one is just declarative, what you could do. I like the questions because what draws you into a website is going to be different for every person. So when you're working in web or graphic design, it's good to know what your audience is going to be attracted to. And one of the ways you can incorporate this into your coursework is to create a survey and then look at the data and then graph the data in your favorite way. And then have the participants justify their reasons for responding the way that they did. Okay. Now we're into some content. As I mentioned before, the P through 8 are grade by grade in content domains. And the high school is arranged by conceptual categories. So here are the big 6 conceptual categories. And you'll notice that it's much different than how high school is right now with integrated algebra 1, integrated geometry, integrated algebra 2, and trig. So for example, if you're trying to create an algebra 1 type course, you might want to cherry pick from number and quantity, algebra, and functions. Okay, the star by modeling shows up in the actual performance indicators in the standards. So if you see a performance indicator with a star by it, it means, hey, this is a great place to have modeling involved. So modeling is not intended to be a standalone conceptual category. It's supposed to be woven into the other 5. Okay, here comes the recognizing the math part. I was on the NRC CTE website, and I found some really cool sample curriculum maps for different CTE courses. This is one of the examples that I first bumped into. And as you can see, they looked at concepts or applications for CTE, and then they flushed out some embedded math concepts. And then the bottom portion of this, they actually hooked in some middle school and some high school Common Core standards for it. And I thought, really cool. All right. So recognizing the math in a different course, I saw, okay, setting dining room and side stand, and then what they actually have to do is determine equipment needed and place the equipment. And then as I looked at the last 3 columns, nothing was there. So the math was not yet recognized. So bringing this to this experience today, I thought, okay, let's see if there's math we can recognize and see what you think. Okay, this is from a Pisa 2012 exam, and it shows a pretty applicable situation to what we just looked at. Now, the only problem is that there's something missing. Because right now, as a math person, I'm looking at this, and this means nothing to me because I don't have this. I don't have the key or the scale or what anything represents on this graph paper. Okay? So I need to know what a square represents. So we're looking at 0.5 meters by 0.5 meters, and that's the international spelling of meters. Okay, so the embedded math concepts would be about area and perimeter. So anytime you have different geometric figures, your mind can go right to something to do with area and something to do with perimeter. Now, since we're probably going to have to calculate something like that, we want to embed a 10 to precision. We also want to look for and make use of structure, because we have a lot of different geometric shapes going on in that diagram. And what it boils down to is, if you're in the situation, you could have your students do a scale drawing or come up with some floor plans. So recognizing that, you could also take it one step further. Embedded in this item is part 2, where it gives you this little schematic with the tables and chairs. And notice the dashed circle surrounding the table and chairs. Okay? The 1.5 meters indicated by the line at the bottom is going to represent the diameter of the circle. So now you have something to move around on the diagram. And here are the constraints. You have each set needs to be at least 0.5 meters away from walls. Now that makes sense, because while you're eating, you don't want to be bumping into the walls with your elbows or whatever. And then you should be at least 0.5 meters away from other people. So pretty real world. So the part of this item is to find the maximum number of sets that can fit into the shaded seating area. So you would take another look at this, and looking at that rectangle, here's what you would do. You would use the scale, the fact that each little square represents 0.5 by 0.5 meters, and the given constraints about being away from the walls and away from the other sets, and find the number of circles that fit into the rectangle. And if you could look back at this PowerPoint and want to do this problem, the answer is 4. Because notice that the question, I'm going to flip back for a second, talked about the maximum number of sets that could fit into the shaded area. So if you came out with a number like 4.2 or something, you have to go down because you can't have 0.2 of a table. That would be awkward. Okay. So once again, using the scale and the constraints, you'd find the number of circles that fit into the rectangle. All right. So then I took a stroll through another area for automotive, and I came up with the safety. And once again, the math wasn't recognized, so what a neat opportunity to try to pick out some math. So in the second column, there are some things that lend themselves to math. The tool usage, the equipment usage, the emergency procedures, and the air pressure in particular. So here are some ideas for some embedded math concepts. A lot of people, in case of an emergency, aren't going to be really good at reading a checklist. Oh, first I have to do, and then I have to do. So I thought it might be a good idea, in this case, if students could create a flow chart for emergency procedures. And then for equipment usage, the ratchets would be nice, because usually right on the ratchets they have all the little fractions and the sizes. And then if you're going to go with a flow chart, that would be modeling with mathematics. And if you remember what a flow chart looks like, it utilizes a lot of different geometric shapes. There's a rhombus, an ellipse, or a circle, or a rectangle, whatever you'd like to use. And then if you're talking air pressure, you're talking the ratio of pounds to square inches, or PSI. And then you'd reason abstractly and quantitatively, because sometimes you don't know what you're looking at. And you have to get the abstract or the big global type picture before you could knock it down to what kind of stuff you need. Okay. So now that we've recognized some math, let's see if we can maximize the math. All right. So if you're a criminal justice type person, you want to look at some statistics. So again, from the released Pisa items, here's the scene. You have a graph. And a reporter showed it on TV and made the claim that there's a huge increase in the number of robberies from 1998 to 1999. Okay. Is the reporter's statement reasonable? And give an answer to support it. Now, the first thing that might catch your attention is this. This little jagged piece of the vertical axis. Okay. That's the big clue right there. So take about 10, 15 seconds to give an explanation to support your answer, yes or no. Okay. Hopefully you said it's not reasonable or no. And here are some possible explanations. You're seeing a very small part of the graph, and the percent increase isn't really huge, and that could be verified by looking at the vertical scale, grabbing the number for each bar, and creating a percent increase and say, yeah, it's not that big. Now the thing is, you only have 2 years represented, so you only have one change from 98 to 99. You'd need really at least 2 changes to say one is huge and one is small or whatever. And really, what is the definition of huge anyway? That's pretty subjective. Okay, whoa. This actually is, again, a released Pisa item, and I used this with teachers in a workshop in high school a couple years ago. And this snail-type diagram is really cool for hitting math practice number 1. Make sense of problems and persevere in solving them. Because when I first saw it, I was a little bit turned off by it. And I thought, all right, what is this? How are we going to get through this? How would I ever use it with kids, use it with teachers, whatever? So because the brain likes the chunking of information, I said, all right, well, let's just focus on one thing at a time. So the distance traveled during the driver's reaction time, you're going to follow along counterclockwise and look at those numbers, starting with 37.5 meters and then going around again counterclockwise, 35.4, 33.3, and so on and so on. Now, you notice that the circle in the middle with the speed indicator is on 80, but students wanted to see somebody drive really fast. So we looked at this one at 110 and also talked about the decrease in reaction time the higher the speed. So there's another type of relationship you could point out. So if we just take a smaller piece of this graph and again take a look at what happens when you travel at 110 miles an hour, what is the distance traveled during the driver's reaction time? And as I said earlier, it is 22.9 meters. So if you're feeling comfortable working with big, huge diagrams such as this, you can really work out a lot of different scenarios. You can advocate for driving responsibly. You can talk about the metric system versus the U.S. customary system and what would the actual U.S. speed you'd be driving if it was 110 in metric, that kind of stuff. So that, again, can be found in the Pisa released items. Okay, so maximizing math in culinary arts. You have a recipe given here for 100 milliliters of dressing. You have 3 different ingredients: salad oil, vinegar, and soy sauce. Okay, note again the use of the metric unit. And the question is, how many milliliters of salad oil do you need to make 150 milliliters of the dressing? All right, well, before we get to the next slide, think about some conversations you would have with your students to try to engage them in thinking mathematically. If you have a recipe for 100 milliliters and you need to make 150 milliliters, what's going to happen to the amount of each ingredient? Does it need to increase, or does it need to decrease? Or does it need to stay the same? Now that might seem like a very basic concept, but this is an opportunity for many students to gain some confidence and say, well, if I'm making more, then I need more of everything, And that's great, because then they're correct, and then they can get to the part where you have to set up this proportion and solve it. So there are different ways to set up the proportion. The way in which this proportion is set up is that you have the 100 that represents the recipe how much the recipe yields, over the amount of salad oil necessary, and that'd be equal to the new recipe of 150 over your S, or your unknown amount of salad dressing. So if you take some cross products, you would get 100 times S equals 150 times 60, and solving for S, you get 90 milliliters of salad oil. So knowing that you have to come up with a larger number ahead of time, that's a nice way to check your answer. Now, one of the ways in which you could extend this is to have them figure the amounts for the vinegar, original amount 30, and the soy sauce, original amount 10. You can also extend it by having them create a lesser amount than 100. Okay? So that's how you maximize the math in that scenario. Okay, one last scenario that we're going to entertain is we're going to look at some environmental conservation about decomposition of litter. So take a stroll through that table and see if you can figure out why they're asking for the information, why a bar graph is unsuitable. Now think about what a bar graph looks like. We just saw one earlier in the criminal justice world. Now notice a couple of things going on here that actually kind of struck me as funny. If you think about a bar graph, you need to represent data in discrete amounts. So if you have bananas, you have to have a bar for bananas. If you have an orange, you need to have a bar for orange. You need to have a bar for cardboard boxes, the gum, the newspapers, and the polystyrene cups. So it's a discrete kind of representation of data. So the first thing that popped out at me is, I have 2 decomp times that are exactly the same. Okay. I also, looking at this one, a few days. If you want to attend to precision, that's not exactly precise. Then the last one also caught my eye, over 100 years. Okay, so since they're already telling you that it's unsuitable, now you're going to have to look at why. Okay, so here we go. Now there is a big variance in this data. You go from the polystyrene cups more than 100 years to the newspapers just a few days. And the units on a bar graph all have to be the same. So if you're thinking about this bar graph, and let's just say you have curious students who want to try to make it work and will argue that it can, what you can say is, well, are you going to convert everything to days, or are you going to convert everything to years? And how are you going to name a few? Exactly how many days are in a few, right? We usually say in ELA that a few, 3 or more, but that's not really precise. Okay, so I want to thank the resources that I found. I wish I could speak to them personally. The best I could do is give them these props and reference their work. It's really some cool stuff that I found. Again, if you want to look at the Pisa assessment, that is the second one from the bottom, I would recommend that you go there and see what kind of stuff you can find. Because as I said, the Pisa is really real-worldy, math literacy type stuff. And not only do I have a math degree, I also have a degree in literacy just because I wanted to see what was going on the other side. I also grew up with a dad who, God rest his soul, was a high school English teacher. So we always were exposed to really precise vocabulary and really big words. And kids really love big words. And if you're thinking about the ways in which your students speak about math, and if it's not that precise, then you can take a lot of different opportunities to have them get precise. You can have them just look around in life. You can have them watching TV, because they will, and jot down some of the things that they're starting to hear as mathy, and have them bring it into the classroom and discuss it with you and why they think it's mathy and all that sort of stuff. Okay. Go to road sign math, that last one there. That is pretty funny. That was the picture I found with the perfect squares on it, and to me it looked like somebody was hanging a camera out the window and just happened to drive by it and notice it real quick and snap it. So I'm not advocating, I'm advocating don't math and drive is what I'm advocating. I have been known, actually, and I freely admit this, to pulling over on the side of the road and taking a picture of a weird little math sign, and I've compiled a bunch of them, and I use them in my presentations all around the country. Because I travel a lot, and math is everywhere. Okay, so it's 4:14 according to my clock, which is, wow, okay, a time for questions now. Nope.
All right, Gil. We had a few questions throughout the webinar. If you'd like to ask a question to Gail right now, you can type it into the questions pane on your control panel. Gail, the first question we had come in for you was, you mentioned math literacy. What are some things I can do in my classroom?
Oh, okay. Some of the things that I've done in my classrooms and I've seen in other classrooms is to put up a word wall. And a word wall can be a bunch of different individual poster type things with frequently used math terms. Like if you're doing a unit on, well, back to perfect squares, the Pythagorean theorem, what are some commonly used terms associated with the Pythagorean theorem and right triangles and all of that sort of stuff? Now, there's a lot of prefab stuff you can order from catalogs and buy in teacher stores, and that's all good because I'm a big fan of the visuals. What I found helps more in reinforce it with students is that you have the students create it themselves, because then they take more ownership over the work, and they can come in and go, ooh, I did that, miss, and have a real sense of accomplishment that everybody's looking at their stuff. Another thing you can do, and I think I mentioned quick writes, is if you have a do now or a bell ringer or some way to open the lesson or review the material from the day before, it doesn't have to be a huge prompt. What do you remember from yesterday? Something like that. But you want to give your kids many, many opportunities built in to write in math. And then that way you have strong evidence of their thinking, and then you can help them refine it and make it more precise. And when you speak to students about math, you can use the precise terminology because that's the listening portion of the big four in literacy: read, write, listen, and speak. And thank you for that question. It's a good question. Are there any others?
The question is, what do you think is a reasonable policy for allowing my students to use calculators to solve some of the problems that we saw today?
The calculator thing. As long as it's a scientific calculator, which means that it can do order of operations automatically, then that's great. I think that calculators, as long as they're not overly dependent on them, and as long as they show their work, they have to show each step that they took. They have to use, they use the calculator to get the answer. Then I want to see that check. I want to know that it works because, it's the age-old thing. If you push an incorrect button and you take the answer as the answer and you don't check it, then the whole thing's out the window. So that's kind of how I ran things in my room, and that's how I advocate it, because you want to make sure that they have the process down correctly. And please, please, please check your work.
All right, at this time we have one more question. As a reminder, if you'd like to ask Gail a question, type it into the questions panel on your control pane. The last question we have today is, do you have any more suggestions for recognizing and maximizing math in everyday life?
Oh, yes. Let me hook back into zero. listen for the O versus 0 thing. Try to reinforce that. If you take anything away from this webinar today, I hope it's that, O for 0. What I like to do, too, is help other people recognize and maximize. I recently went to do a workshop in South Jersey, and I was at my favorite chicken place, and it was a new cashier, and she gave me the total of $7.58. I gave her $20.60. Okay? She literally raced for the calculator and still got the answer incorrect, which leads back to the question that was just asked about the calculators. So I had a nice discussion about place value with this very sweet young woman, and she was very embarrassed, and she said, well, how do you know so much about this? And I said, well, I'm a math teacher. She's like, oh, no, I feel even worse. I said, oh, no, honey, don't, just need to get, some place value back in you. When you look around in math, I mean, even as you're passing by a gas station or anything that you can recognize to kind of stick in your brain and see it in a different way, you can start to change your perception on where math is and how frequently it shows up in real life. And again, watch the news. The news always comes up with really interesting statistics or mathy kind of things, and even listen to the way that they pronounce numbers. Listen, watch football. It's football season if you're into that. Look at how you can count by 7 for touchdowns, count by 3, count by 6 for touchdowns, and then +1 is an extra point. Just think about reframing the everyday things that you see and take that little sidestep in perspective and just try to say, how can I look at this just a little more mathy, just a little more differently? And then you'll start your, create those new neural mathy pathways in your brain. Then you can take it to your classroom and do it every day even more. Thank you for that question.
Great. At this time, there are no more questions. So that concludes today's webinar. With that, thank you for joining us today for this webinar presented by Gail Palka. As a reminder, this webinar will be available for viewing at nyctecenter.org within 72 hours.